Thank you. Good evening, class. So good to see you. So it seems I already met some of you last night. And again, I'm glad to see you in this classroom. All right. My name is Lee Seok-gu, Associate Professor in Triple E. So I'm gonna be the course coordinator and also the lecturer of the first half of this IE 105, and also I'm gonna be the tutor of the second tutorial class as well. I'm gonna spend 4 weeks for this lecture session with you. First of all, let me give you the briefing of this course. So, introduction to IE 1005. Okay, so the title of this lecture is From Computational Thinking to Programming. So, first of all, what is the computational thinking? So, it is the thoughtful process. Yes, it's quite obvious because it is a kind of thinking, but what's the difference of the computational thinking and then the thinking of the human? It might be a little bit different. So for the thinking of the human, it might be a little bit abstract because you're already thinking about it, but actually you don't notice it, but you will just skip it when you think about certain process. But computational thinking, yes, it has to be detailed and accurate. And mostly, this computational thinking involves the formulation of the problem. So, we have a certain purpose for this computational thinking. So, we want to solve the problem. We want to develop something for our convenience or some entertaining matters. Then, after this formulation of the problem, this computational thinking will express the solution in a way that computer can effectively carry out. Because the thinking way of the computer, you mean the electronic device, the CPU or GPU, something like that. So they have a different structure of the thinking compared to humans thinking. All right, then this computational thinking will be translated to the programming. Because our human, if we have our own language, right? Then the computer has its own language as well. But their structure is totally different. Then, so we want to make computer is doing something, then we need to give the very detailed instruction one by one. For example, if I ask you to come to this lecture room at 7 p.m., then I just say like that. Come to lecture room, lecture theater, 29 until 7 p.m. Then, as you see, you came here, right? I can just give you very simple instruction to you. I don't have to explain what transportation you have to use, what direction you have to take, right? But let's imagine we have a robot. Then I have to give it to very detailed instruction. If the robot is staying at home, so I may say open the door and walk out to the home and find the bus stop and take the bus number ABC, something like that, and have a transit to MRT. Even I have to give even more detailed instruction. But you know what? Actually, you are thinking about it, but you don't notice it because it's too natural. But for the computer, we need to give this kind of instruction one by one. It has to be very detailed. Okay, then this instruction must be programmed or coded. Why? Because this machine cannot understand our natural language. So we need to use this programming language, like a C, Java, Python, something like that. And then this programming language will form this computer program. So in this course, I want you to explain, you are able to explain the programming concept, and then you can write the basic computer programs based on the programming language taught in this course. And then I hope that you are able to apply the concept learned in this course and translate it to computational thinking to actual computer programs. All right, so this is the list of the textbook for this course, but I know nobody buy the textbook or read it. So yeah, you can just use, study the lecture note if necessary. That should be enough. All right, then this is the outline of the course. In the part 1, so I will introduce what computer is doing, an overview of the C language, then the fundamental data types. So you will declare variables. Then in this C language, you need to define the type of them. Then various C operators. What is the most well-known, widely used operator? Arithmetic operators, right? Addition, subtraction, multiplication, division. And you will learn about something else used in this C language. And you will learn about the various functions. And then I believe these two parts, decision making and the loop, is the core of this course. So as long as you have the proper understanding of this decision making process and loop, then yes, you will be very successful in this course. And also you will be successful in the upcoming coding task. All right, then in the second part, Dr. Yong Jae-ki will cover the second part. So you will learn about the functions. So in the first part, you will learn about the standard library functions. It is already defined function in this C language. And sometimes you want to make your own functions. It will be more complicated and will be more useful for your own coding. Then you will learn about these functions. And then once you combine various functions, then you can have modular programming to make your coding more efficient. Then you will learn about the arrays and pointers in the second 4 weeks. And notice that so you will have a 3 hours lecture every week from week 1 to week 8. And you will have a 3-hour tutorial session per week. It will begin in week 2. So, which means you don't have a tutorial class in this week. So, yes, but the tutorial will end in week 9. And then week 10, so did you see my announcement in the NTULearn website? So in week 10, Friday night, you will take the final quiz. So please book your time. All right, so this is the detailed schedule. In this week, no tutorial, but in the lecture, so I will introduce the basic, the structure of the computer and the programming, and then I will give you the overview of the C language. In the second week, I will continue about the overview of the C language, and I will handle this fundamental data type. And you can notice that the schedule of the tutorial comes 1 week later from this lecture. Okay, in week 3, so you will learn about the C operators, functions, and the beginning of the decision-making process. But I noticed that in week 3 we have a holiday, right? So then I'm going to share the recorded lecture, and then I will stay in online in the certain time for the Q&A session. So if you have any question, you can access the Teams, then you can ask me any questions. So I'll give you more detailed the instruction when the week 3 is coming. Okay, in the week 4, so you will learn about the decision making and the loop. Okay, then in the remaining 4 weeks, you will learn about functions, modular programming, arrays, and the scope and lifetime, pointers, and again, so you will take a final quiz in week 10. All right, so probably this is the most important slide for you. This is the assessment summary. For the first component is the class participation. So it will be assessed by tutors in your tutorial class. It takes 10% of the total mark. Then you will have 2 home assignments. Each takes 10% of the total mark. And then you will take practical test 1 and 2. It takes 20% of the total mark. And then final quiz takes 30%, which is very important, right? Okay, and notice that the mark of these 3 components will be released in the NTU Learn website. Okay, so first, let me talk about this class participation. So this is not about the attendance of the class, but that doesn't mean that you are free to have absent of the class. So please come to the lecture and tutorial class. So, so especially in the tutorial class, we will ask a couple of questions, and also since you practice the coding in the computer lab, so we will check your attitude most of the time. So this computer is very attractive equipment to have some entertainment, right? So yes, I know that you are already matured people, so you won't do that, but just in case, I like highlight. In my previous experience, some of students are playing game, watching video, watching webtoon, something like that. And yes, so this non-professional attitude will affect this class participation. Okay, then let's talk about these 2 home assignments. So each home assignment takes 10% of the mark. So I will give you the 1 coding task for each home assignment. Then you will be given about a week. Then you will make a code and upload the code within due date. Then we'll give you the mark. Okay, then notice that so you need to make a code, and also I will ask you to submit the video recording of your explanation of the code. So this is also a very important component in the assessment of this home assignment. So remember, you have to submit your code file, and also you will submit 2-minute video recording. So detailed instruction of this video recording will be shared when you submit this home assignment. Yeah, of course, copying from others is disallowed, right? Then it will incur heavy penalty. Do you have any question for this assessment so far? All right, then let's move on. Okay, so in the tutorial class, you will take 2 practical tests. Each test takes 20% of the total mark. This is not small, so please don't ignore it. So this is the restricted open book test. What is the meaning of restricted? You can use the lecture note downloaded in the NTU Learn website. Then you can also use the tutorial solution. However, you cannot use Google. You cannot use ChatGPT. Yes, you are not allowed to use AI at all. So you can use only the lecture note. Then you will be given 1 programming question. So during 45 minutes, you will complete the coding. Then you will submit it in the NTU Learn website. So this is how this test is going. So you will take the test in week 5 and week 8. So please do not absent, especially in this week 5 and week 8. Otherwise, we cannot give you the mark. So more details of this test will be given in the tutorial class. Okay, quiz. It takes 30%. So yeah, usually we give you the 20 MCQs. MCQ means, okay, we usually give the 5 choices. That means you have a 20% of chance of getting answer, right? Okay, then this question is mostly about the tracking the value of the variables and predicting the outcome of the given code. So you should be able to read the code and understand it. So as we have the tutorial and lectures, yes, you will find so what would be the question in this final quiz. Of course, this is the closed book test and MCQ. And remember, the date is 8 p.m., 17th July. So please book your time. Any question? Okay, then let's move on. So you can find the most of the resources in the NTU Learn website. So there are 2 websites. The one is for the lecture, and the other one is for the tutorial. So if you go to the lecture website, on the front page, you can find these contents. So in here, you can download the lecture note and also the extra questions you can try. And this second one is for the second part. Then, so you can also watch the recorded video in this media gallery. And the last one, this is the instruction how you can take a video recording for this home assignment. Yes, I give you very detailed instructions, so you must follow that. Otherwise, I have to deduct your mark. Okay, advice. So in this course, you're gonna learn about the C programming language. So just like learning any new language like Japanese, French, Spanish, something like that, yes, practice is very important. So I hope that you can practice this C programming regularly, and if necessary, I can provide you the extra questions. Actually, there are many extra questions already in this NTU Learn website. So if you don't have the time to try it, at least do your best during the tutorial class. So in the tutorial class, you'll be given 4 to 5, or actually a little bit more than that, 6 to 7 tutorial questions. They are mostly the coding task. So I hope that you can try it. And if you have any question and problem, then you can seek the help from the tutors. All right. Then, so notice that there are 2 tutorial groups. So find your tutorial group number carefully. Then please join in the registered tutorial group. And do not attend another class because we have a limited number of computers. And then once you go to the computer lab next week, so there is the attendance list. So please sign the form and then find your seat number. So you can only be seated in the assigned seat number. Okay, then last one. Please check your NTU email regularly because most of the announcement will be given by this email. All right, so do you have any questions so far? Everything's good? All right, then again, the final quiz, so please book your schedule. Final quiz is at from 8 p.m. to 9 p.m. on 17th July, Friday night. And the last one. So notice that you are not allowed to use AI, like a ChatGPT, Gemini, Claude, in entire courses for the assignment, test, and even during the tutorial. So if you have any question, please seek your help to the tutors. Okay? All right, then, so this is my contact, the email. So if you have any question, so feel free to send me email. So I'm the course coordinator, and also I'm the lecturer of the first half of the course. The second part will be covered by Dr. Yong-Jae Ki. So his email is here. So you can download this lecture note in the NTU Learn website. And for the tutorial lessons, please contact your tutor. All right. That's all for today. No, of course not. Sorry. All right, then let's begin lesson 1. Computers and programming. So if you are closely working with the computers, or you are kind of guru of the hardcore gaming, and you are very interested in the performance of the computer, then it might be quite easy. All right. This is what computer does, right? So if you are working in the office, then you can do a lot of documentation work. Gaming. Yes, you need the high performance computer for this gaming, right? And the video chatting, and yeah, if you go to the mall, then you can find this kind of kiosk. Then, yes, computer is everywhere. And even in your pocket, this is a quite high performance computer as well, right? Okay. Then, these computers are doing a lot of things. It's impossible to count what the computer is doing. But if I have to simplify what computer is doing, then I may divide them to these 3 steps. Input, process, output. So, yes, you're going to order something to the computer, and you will provide certain information or data or signal, and then the computer will accept those data. This is the input. And then after that, computer itself will do the processing. Then eventually it will give you certain outcome. This is the output of the process. Then what kind of input can you consider? If you think about very conventional computer, like this desktop or laptop computer, typing is one of widely used input, right? And if you have a touch screen, this is also the input to the computer. Mic, the sound information will be inserted to the computer, and mouse, the information of the position, right? So you can think about these kind of inputs. And what about output? Mostly, the computer will give you the output on the screen, monitor. So it will give you the visual output. Then it also gives you sound, vibration, and even hard copy printing, like this, right? So if you click MP3 file, this is the input. Then computer do the process. It will give you the sound information as an output, right? This is what computer is doing. Okay, then now, yes, we want to learn about this process. In this process, so basically there are 3 main components of the computer are involved. The first one is secondary storage. So it stores the large amount of the data, and then we have a primary storage system. The data is transferred from secondary to the primary storage. And then this primary storage directly communicated with CPU. And then these are controlled by the instruction in the program. Okay, then let's talk about the secondary storage. So basically this is the hard disk drive or solid state drive, something like that. And even thumb drive, USB thumb drive is one of kind of secondary storage. Its characteristic is very cheap and permanent storage of the data. What is the meaning of the permanent? So when you cut off the power, you still can store the data. So hard disk drive, solid state, and even the compact disc. This CD or DVD, it stores the data. And if you need the massive amount of the data storage, then you can use these magnetic tapes as well. Okay, notice that the characteristic is cheap and permanent. How about the primary storage? So when you buy your smartphone, laptop, computer, or PC for your game, then actually you are taking care of the specification of it. The one of the important specification is capacity of the RAM, right? So in these days, this smartphone has 8 gigabyte or 16 gigabyte, even more. And my laptop has 16 gigabyte maybe. Yes, that's the capacity of this RAM. RAM is, the full name is random access memory. So this is the primary storage system in the computer. So what is the characteristics? It is very fast compared to the secondary storage. Yes, it is very fast, so you can have the fast communication with this CPU. Then, yes, as you know, all of this semiconductor device handles the binary data, 1 or 0, which means on and off, right? Okay, then in this memory, so there is a certain small sections of the memories. Then it is called as a memory cell. This memory cell stores 1 byte of the data. 1 byte means 8 bits. What is the meaning of bit? Bit is one pair of 1 and 0. So if you have a 1 bit, you can express 2 cases. If you have a 2 bit, you can express 4 cases, 2 times 2. If you have 5 bits, 2 to the power of 5, 32. You can express 32 cases. So 1 byte means 8 bits. So 2 to the power of 8, which is 256. So this is the 1 byte. Okay. Yes, this RAM has a very high speed compared to the secondary storage, like a solid state or hard disk drive. Then you may ask, then why don't you use RAM for the entire data storage? Then it's going to be super fast, right? But while it is very fast, one of the characteristics is the data is volatile, not permanent. So once you turn off the computer, the data stored in this RAM will be totally disappeared. You're going to have a reset. So this is the characteristic. So you cannot use this RAM for the secondary storage system. And also, it is very expensive compared to the secondary storage. So in this computer, we usually have a 16 gigabyte, 32 gigabyte of the RAM. Why don't you have more? So think about your hard disk, the solid state disk capacity. In these days, you may have 1 terabyte, 2 terabyte, very large. If you have the 1 terabyte of the RAM memory, I don't know, you may have to pay about 10K or more than that. Yes, it's very expensive. So if you want to store, like a movie, something like that, very big file, you need a cheap secondary storage system. Okay, next. Let's think about this memory cell. Then each cell can hold 1 byte of the data. 1 byte means 8 bits from 0 to 255. The total number is 256, right? And then it also has certain address of the memory cell so that you can easily access each memory cell. Then in the memory cell, sometimes you can store this kind of complicated real number. You can also store the string or letter and integer values as well. Then this data has address, and in your programming, when computer access this data, it will follow this address numbers. Okay, then how to express the size of the memory? It might be very familiar to you. 1 kilobyte, KB, 1 megabyte, 1 gigabyte, 1 terabyte. So actually the 1 kilobyte is the 2 to the power of 10 bytes. So if you want to use accurate number, it has to be 1024 bytes. And 1 megabyte is the 2 to the power of 20, which is 1024 kilobyte. But in short, to make it simple, we just use this number, 1000. And gigabyte is same. All right, so let's imagine you bought the thumb drive. The capacity is, let's say, 16 gigabyte. Then, if you plug in this thumb drive, and then you will see the icon of that drive, and go to the property in your PC. Then this property window will give you the actual capacity of the memory. Actually, this is not exactly 16 gigabyte because in the accurate value, it counts this byte. Okay, then let's move on to the CPU. Actually, the CPU is considered as the brain, real brain of the PC computer. Then this CPU mainly has 3 components. The one is ALU, arithmetic logic unit, and registers, control unit. Then this ALU is a genuine brain of the CPU. So this ALU unit have arithmetic operations. Actually, it handles the numbers. And also it has logical operations. Then this CPU also has a small memory cells. It is adjacent to the ALU, so it has a very fast communication with the ALU. Then this control unit controls the flow of the data between registers and ALU. All right, then to control this component and the flow of the data, we need an instruction, which is the program. Then this program, so computer need to understand this program, right? So when you say something in your human natural language, actually computer cannot understand. Then this language or your idea, computational thinking, has to be translated to the language that computer can understand, right? So this process is called as programming or coding. So there are 2 kinds of programming languages. The one is low-level language. The second is high-level language. So this program language is an artificial language. Of course, the human developed this language artificially, and it is consists of the set of special words, which is keyword, and the set of the rules. So this is called a syntax or grammar. Then in this low-level language, we have a machine language, assembly language. This machine language is kind of real language that computer can understand. So this machine language is consists of 1 and 0, as you can see here. Then once you insert this order of the 1 and 0s, then this computer can understand the meaning of it. But the problem is, computer can understand machine language, but like us, normal people cannot understand this language. It's too complicated, right? So, to overcome this, solve this problem, so we have a high-level language. Fortran, C, C#, Java, Python, something like that. There are various high-level languages. Then in this course, you will learn the C language, right? Okay. Then how can we use this high-level language while we don't understand low-level? These high-level languages consist of the simple English words, like a print, read, write, go, stop, something like that. So these languages uses these natural words. And then once you write this high-level language using this natural word, then actually you use the compiler. This is the another translator. It translates your high-level language based on this English word to the actual machine language. Then computer understand your coding written by this high-level language. So since this language uses the natural word, it's easy to read and easy to write and easy to understand, right? Okay, so I better skip this part. Okay, but in this high-level language, it is very strict for the grammar. Let me give you an example. In the human language, yes, our language also has the grammar, right? But sometimes it is very generous. I mean, for example, he don't like it. Actually, this is wrong. It has a wrong grammar, right? But you don't understand it, right? Although there is error of the grammar, you can understand this, right? But you know, if you have this kind of error of the grammar in the computer programming language, then it is very strict. You cannot translate it to the machine language. So in this high-level language, if you have certain grammar error, then we call it as syntax error. So error in grammar. Then there are many kind of errors, not only the syntax error. Sometimes, yes, logical errors. Your grammar, syntax are all correct. But your logic is wrong. In that case, you know, your program will not work properly. For example, you made a program to add number 1 and number 2. Then, in the inside of the program, you may add number 1 plus number 2. Then, by the mistake, you typed number 1 minus number 2. Grammar is correct, right? But you won't get the right outcome. This is a simple example of the logical error. Another type of the error is runtime error. Sometimes, in the week 4, you will learn about the loop. So I believe computer is really doing at the repetitive job, the tedious job. Like add number from 1 to million, something like that. Of course, if you know the formula, you can calculate it very fast. But actually, computer add numbers one by one very quickly. But sometimes, if you have the long setting of the loop, then computer doesn't know when to stop. You will learn the computer infinite time. We call it as runtime error. And sometimes the number is divided by 0. You know the concept of the infinity, but computer doesn't. So once the number is divided by 0, it's going to be runtime error. So remember, there are 3 types of the errors. Okay, then now you want to make a program. Then what's going to be the process? So before you writing the actual code using the C language, first of all, you need to have a process of the problem solving. First of all, first step is problem specification. You need to find what to solve, and then what is the task given to you. And then think about this problem and find the solution. How to fix it, how to solve it, how to make it. And then you will have an algorithmic design based on the computational thinking. So algorithmic design means you're going to make an order of the instruction to give to the computer. And then once you set this algorithm, you will start writing code using your preferred language. In this course, you will use C language. And then after you're writing code, this is not the end. You're going to test your code. You're going to have a debugging process. Debugging means you will fix the error of the code. And in the testing step, yes, you need to verify if your program gives the right outcome or not. You need to test it. And then once you complete it, you'll move on to the maintenance process. So this is the overall programming process. Then, what is algorithm? So this algorithm is set up precisely stated, finely sequence the order of the executable step for solving a program. So in this algorithm, you will give very detailed instructions to the computer one by one. So once you set the right suitable algorithm, then you can say that most of coding is done, programming is done. Actually, making code is much easier than making the right and efficient algorithm. So when you develop the algorithm, before you write the actual programming language, you can use just informal English-like statement. It is known as pseudocode. This is not the formal programming language, but you can use any word as you want. But at least you and the other people need to understand it. So instead of writing pseudocode, sometimes you can also use the flowchart, but it is not covered in this course. But you will learn about this flowchart in the later course, in the year 2. Okay, then I would like to give you the one example of the pseudocode. Okay, so this is the problem. To calculate the area of a circle given its radius. Okay, so let's write the pseudocode together. The first step, start your program. Then next, input radius. Okay, now we want to calculate area of the circle given its radius. So we need to give the radius to the program. So input radius, and then what's going to be next? Calculate area. Do you remember the formula of the area of the circle? Right? So circle area equals pi times radius. Calculate it. Okay, is it the end of the program? No. Once you have an input, then you're going to do the process. Then what's the next? Output. Right? You need to show the outcome. Output, circle, area. Then end the program. So this is the pseudocode. You can use any word. So actually I mentioned that English-like word. But if you are prefer, you can use your own language. It is okay. There's no specific grammar. Then there's tons of variation. For example, instead of this pseudocode, you can use get, read, input, write, print, something like that. So let's write another pseudocode. Start. Get radius. Calculate circle area. Circle area equals pi times radius. Then display circle area. End the program. So any word is fine for this pseudocode, as long as you and the other people can understand. Okay, then let's try the second example. To find the larger of two user input numbers, number 1 and number 2. Okay, then imagine we have a two number, 3 and 8. Which one is larger? Yes, 8. You don't need such detailed instruction of the process to find the answer, right? But computer requires detailed instruction. So it's going to be written in this pseudocode. First, start. And then next. So we need these two numbers, right? Input, number 1, and number 2. You need to obtain these two values. Next, you have to compare it, right? If number 1 is larger than number 2, then what do? Output. Yes. Or this way. So there are tons of ways of the algorithm. So in my case, set max equals number 1. Else means the opposite case. Then max equals number 2. At the end of the program, output max, then end the program. If number 1 is larger than number 2, then max will be number 1. So this is decision making. If condition A, then you're going to do something. Otherwise, you're going to something else. It's a matter of choice. So this is kind of decision making process. Okay, another example. There's a various possible pseudocode. Start, input number 1 and number 2. Set max equals number 1. So now we assume that number 1 is the largest number. And then what do? If number 2 is larger than max, switch it. Set max equals number 2. And if. Why? If the number 1 is larger than number 2, you can just keep it, right? You don't have to change it. Okay, then output max. Display max. And then end the program. Okay, so this is the one of simple example of the pseudocode. All right, then next. Calculate the sum of two numbers provided by the user. Okay, then let's try it together. Oops. Shall we take 5-minute break? Okay, then please come back until 8:10. Okay? guys are ready? What? Ah. So you guys are ready? Okay, then let's resume the lecture. So this is the third example of the pseudocode. Calculate the sum of two numbers provided by the users. So please take a seat. All right, then let's write the pseudocode together. First of all, you will write start or begin whatever meaningful word. Okay, then next, we need to get the two numbers from the user, right? Okay, then I may say write number 1, number 2. How do you think? It's making sense. You may say write, input, key in, whatever. And then calculate sum. And sum equals number 1 plus number 2. It's very easy, right? Then what's next? Almost the end of the program, right? Now you calculate the sum of two numbers. Then display sum. And then end the program. Is it making sense? Yes. So this is the example of the pseudocode. Calculating the sum of the two numbers. Okay. In the later lecture, so you will learn how to translate this pseudocode. You will learn how to translate this pseudocode to the actual C language. All right, then let's move on to the next example. So check if input number is even or odd. So yes, you know the meaning of the even or odd numbers, right? The even numbers are 2, 4, 6, 8, 10. Odd is 1, 3, 5, 7, 9. Okay, so we're going to write the pseudocode of this problem. Okay, coming back to this prompt. Okay, let's say start. Starting the pseudocode, and then you need to get the number. So input number 1. All right, then what's next? Then we're going to have the decision making. So if the number is even number, you will display message, number is even. If the number is odd, then you will display message, number is odd. So there's a two possible way. Then you will say, if number is odd, then I may say output number is odd. Then else. Else means the another case. Of course, number is even number, right? Output number is even. Then and if, then end the program. But this is not the end. How can you determine the number is odd or even? So in this case, you need a special operator. So you need a mathematical expression to determine whether the number is even or odd. Let's say number, the remainder of number divided by 2 is 1. Then output number is odd. This is more like a mathematical expression, right? Do you remember how to find the remainder? Yes, actually, when you learn about the division in your primary school, so you haven't learned the decimal number yet or fraction. And then when you learn the division, you learn about the remainder. For example, 5 divided by 3, then quotient is 1 and remainder is 2, yes. So if the remainder when the number is divided by 2 is 1, then it is odd number. Okay, then for this you can use special operator. Number percent 2 equals 1. This percent operator returns remainder. So this operation means number is divided by 2, then it will return remainder. Then this one is equals to 1, then number is odd. Else number is even. Then end if, then end the program. Okay, so this is perfect mathematical expression to determine whether the number is even or odd. Then this algorithm also includes decision making, if, else, right? Okay, do you have any question about it? Then let's move on to the next example. Next example is print numbers from 1 to 10. So you want to display numbers from 1 to 10. It looks very simple, right? Okay. Then let's write the pseudocode together. I may give you very simple example. Start the program. Output 1. Output 2. What's going to be next? Output 3. I'm going to skip it. Output 10. End the program. It is working. Don't blame me. Why not? But what if you are asked to display number from 1 to million? What's going to do? Are you going to do the same thing? No. Then it's not meaningful using the computer, right? As I mentioned, computer is very powerful for the repeated work. So in that case, we can think about the loop. So you're going to give the instruction of the repeated work to the computer. Okay, then let's delete it. Then let's write more professional pseudocode using the loop. Start the program, and then for I equals 1 to 10. Or you can say while. This is the natural word. While I equals 1 to 10, output I. Then end while, end the program. So, what is the meaning of it? I is increased from 1 to 10, and during this period, display value of I. So if you say hundred thousand or million, then this pseudocode will display number from 1 to million in this short algorithm, right? So as the number become bigger, then you can find this loop is very useful and effective, right? Then I'm going to try to give a little bit more detailed instruction in this pseudocode. So let's say set I equals 0. Let's say 1, sorry. Now, I is 1. This is the initial value. Okay, while I is less than or equals to 10. What is the meaning of it? As long as I is less than or equals 10, you will repeat below. So now, what is the value of I? I is 1. 1 is less than or equals to 10. Is it true? Yes, it is correct. Then you will learn this part. Output I. And then next. I equals I plus 1. You will increase I. What is the value of I now? 2. Is it valid? Yes, 2 is less than 10. Then display I, which is 2. Then I becomes 3. It is still true you will display 3, 4, 5, 6, 7, 8, 9, 10. Then I becomes 11. Is it true? No. 11 is less than or equals 10. This is not true. Okay, then and while. Then end the program. So I believe this is more accurate and precise pseudocode for this loop. Okay, sometimes you can elaborate it like this. Set max equals 1,000. And then you say while I is less than or equals to max. Then what's going to be the outcome? You will display number from 1 to 1,000, right? Then why did I change it like this? You just change the value of the max. Then you can change the range of the number, right? Okay, so this is the pseudocode considering the loop, the repeated work of the computer. Any question? Okay, then let's move on. Now, we're going to try a little bit more complicated one. Calculate the factorial of input number. So do you remember the factorial? Okay, so I'd like to remind you about it. This is the multiplication of the series of the integers. So for example, you have 3 factorial. 3 factorial means 1 times 2 times 3, which is 6. And if you have 4 factorial, that means 1 times 2 times 3 times 4, which is 6 times 4 means 24. 5 factorial is 120. Right? Okay, so this is the concept of the factorial. Then, so actually you can sense that you need a loop of the multiplication to calculate this factorial. Right? Okay, then let's write the pseudocode together. Start the program and then input number. So actually you will calculate the factorial of this input number. And then set factorial equals 1. This is the initial value. Okay, and then set I equals 1. Then for, let's say while, as I did in the previous pseudocode, while I is less than or equals to number. This input, right? So in this program, if you input 3 for this number, then the range will be 1 to 3 in this loop. Okay, then calculate factorial equals factorial times number. So this is the actual calculation. And then Don't forget the increasing I. I equals I plus 1. Then and while. So what is the meaning of it? So let's track the number one by one. So initially, factorial is 1. Then I equals 1. Let's say your input is, let's say 3. Your input number is 3. Actually, you know the answer. The factorial, 3 factorial is 6. 1 times 2 times 3. So factorial equals 1, I equals 1. Then is it satisfied? Is it true? I 1 is less than 3. It is true. So you can continue. So factorial equals factorial times number. Oh, sorry. This is typo. Out. I. It has to be I. So now it is 1 times 1. Okay. Then now I is 2. Because I equals I plus 1. Now I is 2. Okay. Is it true? I is 2. Number is 3. Yes, it is true. 2 is less than 3. Then what you gonna do? You will do this calculation again. Factorial times I. So factorial is 1. Now I is 2. So factorial becomes 2. And then I becomes 3. Then let's go back. 3 is less than or equals to 3. It is still true. Okay, then let's do this calculation again. Now, what is the value of factorial? 2. So this is 2 and I is 3. Then what is the value? 2 times 3 is 6. And then now I is 4. Is it true? 4 is less than or equals to 3. No, it is not true anymore. Then and while. The next, what do? You have to display outcome, right? Display. So you can use any meaningful English word. Display factorial. Then you will display 6. And then end the program. So this is the example pseudocode calculating factorial of the input number. Any question? No? So if you have a doubt, you have to ask me right now. So next time, you will translate this pseudocode to the actual C program. Code block. That's a very good point. So again, this is not C language. So this is the pseudocode. Pseudocode means we don't have a specific grammar. Yes. So it might be quite different in your code block. So if you key in this, code block will give you a lot of warning sign, right? Because this is not following the grammar of the C language. So for now, you don't have to rely on the grammar of the C. So let's just focus on the developing the algorithm. So that's why we use just the rough English word without any formal grammar. Yes, that's why you have a lot of error sign. But later, once you develop this pseudocode, you will translate it to C language in the code block. Okay, that's very good point. Thank you. All right, so so far, so you practice the writing pseudocode, but this is not the end. As that gentleman asked the question, eventually you need to translate it to the actual C language. So this is called as editing process. So in this editing process, you will write the actual C program based on your pseudocode. So you will create the C file, the source program, as you can see here. Then, yes, this C language will be translated to the machine language, consists of the 0 and 1 that we cannot understand. So this is called as compiling process. So yes, in the computer lab, you will use the CodeBlock software. It has a text editor to write the C program. And then it has a compiling. So your code will be translated machine language automatically. But of course, you shouldn't have the grammar error. Okay, then after this compiling process, this C language to display hello will be translated to the combination of the 0 and 1s, as you can see here. Can you understand this? No, I cannot. Anyway, so it will be implemented in the computer, and then you can execute it. Okay, then what is the linking process? Once you have the compilation, you're going to have the linking process. But in this course, this linking is out of the scope. So this is the meaning of the linking process. So you're going to have the multiple compiled file. And then it will be combined to one executable file. Then it is called as a linking process. For example, have you ever installed any software in your PC? Like an installation of the game or Office, Excel, something like that. So you can find one executable file most of the time. The name usually the name is setup.exe. Do you remember that? Then, beside that executable file, you can find a lot of the files you cannot understand. Right? So, once you execute that executable file, this program access all the other data or program. They are linked each other. So when you develop the program, you will make the various program, and then in the end, you will make a one executable file. This is the linking process. But in this course, your coding will not be very complicated. So yes, you won't have the chance to try linking process. You're going to do only the compiling. Because you need to translate your C program to the machine language to execute it. All right, so to develop this code, you're going to use this code block. It is one of the IDE. What is the IDE? Integrated Development Environment. So this IDE typically contains text editor, as you can see here. So you will write
you will write the C programs in here. And then this code block contains compiler. So this compiler will translate your C language to the machine language. So actually, if you open this code block program in the computer lab next week, you can find these icons. So if you click this gear icon, this is the building, the combination of the compile and link. Then if you click this play button, you will execute your program. Okay, so actually in this lecture, I don't use code block because this code block is not available in the Mac OS. So it is only work in the Windows, but instead of a code block, I use, what's the name of it? VS Code. This is also the free software for this Mac. So in the announcement, I already gave you the detailed instruction how to use this VS Code in the Mac. So if you are the Mac user, so please check the announcement and follow the YouTube clip. If you are the PC user using the Windows, then you can just use code block. That will be better. Because notice that, so you're going to take the 2 tests in the computer lab, right? You must use the desktop PC in the lab. You are not allowed to use your own computer. So the computer in the lab, we already installed the code block, so you must use code block in that desktop PC. So you'd better be familiarized using code block. Okay, so for the summary, so I introduced the computer hardware component, the main memory, the RAM. RAM is volatile and expensive, but very fast. CPU, this is the real brain, and secondary storage is for the massive data storage. So, so we spend most of time to practice writing algorithm and pseudocode, right? So once you write the pseudocode, it will be translated to the C language, and by the compilation process, it will be translated to the machine language as well. All right, but unfortunately, this is not the end of today's lesson. So let me borrow maybe 40 or 50 minutes more. Okay, then let's move on to the next part, the overview of C. Okay, so in the previous part, you practiced writing pseudocode. And now, yes, you'll see how it can be translated. Okay, first of all, so let me introduce about the history of C. This C language was designed by this Dennis Rich in the Bell Lab in early 1970s for writing system software for Unix OS. You are not quite familiar with the Unix OS, but this is the base of this Mac OS and also Linux. Then fun fact is the C was evolved from B. B was created from Basic Combined Programming Language designed by Martin Richard in the 60s. Okay, so again, this program language has specific grammar. Then we have a certain rule book. So everyone want to have the aligned, the same grammar. So this American National Standard Institute established the standard of the C in 1989. So it is called as ANSI C or C89 because it was determined in the 1989. Then not only America, the International Organization of Standardization, ISO, approved this grammar as well. So it is called as ANSI C or ISO C. So we're going to use the grammar determined by this ANSI C in this course. Okay, then in this grammar, so we have a lot of the keywords used in the program. So this is the predefined words with a special meaning, like a int, void, float, and you can find a lot of the keywords as you can see here. Auto, break, case, char means character, int means integer. So you can define the type of the variables using this keyword. So yes, you can use if for the decision making. So do you remember in the pseudocode we use if else, right? And in actual C language we also use the if else. And all right, then next. Beside this keyword, this ANSI C also has a library of the functions. So it already defined very useful functions, as you can see here, kind of built-in functions. So these functions is categorized by the similar theme, and these functions are stored in this standard header files. So you can consider that this header files is a package of the library functions of the similar themes. So if you want to use the specific function in the beginning of the C program, you have to say, I'm going to use this package or that package to use the function in it. Okay? So for example, this stdio.h, this is a standard input and output header file. Then this package includes printf to display something on your screen, scanf, so take the input from the user, and putchar, getchar, they are all related with input of the value and the output of the value. How about the math.h? From the name, actually you can guess what functions are included in this package. This is about the mathematics. So if you want to use the function, the trigonometric functions, sine, cosine, logarithm functions, and the square root, power, something like that, these mathematical functions are included in the package of the math.h. So if your program wants to use these functions, you have to load this math.h header at the beginning of the program. So besides stdio, math, then you can find the various package header files, standard library, C-type. This is about the handling the characters, and time. So in the C-type header file, so there are functions to check the character is letter or not, and also you can use the function to convert the lowercase to uppercase or uppercase to the lowercase, something like that. The time.h contains function related with the time. So it displays current time and convert time to string and it finds the local time, something like that. Standard library functions, actually, so you will use this a lot, especially to generate random number. So for example, you will be asked to make a program of the rock, scissors, papers, like a playing game against the computer. So in that case, you need to generate 3 kinds of random number. Let's say you will generate random number between 1 and 3. Then 1 may reverse rock, 2 may reverse scissors, 3 reverse paper. Then for the computer, it will generate random number between 1 and 3. Then you will key in number between 1 and 3. Then depending on the combination, the program will tell you who won the game. So this is the structure of the rock, scissors, paper game program. Then you need this random number function, rand. So you will learn about more detail in the week 3. All right, finally, this is the first C program in this lecture. Program 2.1. Okay, so you can find these gray colors. Then you can read this C program will print a message on the computer screen. This is for a single line comment. So, can you notice that this is not a C language. This is the just natural human language, right? So, but the color is gray. This is the part of comment, as you can see here. So, if you give the sign of the slash asterisk, and between these 2 parts, you can type any word or letters, sentence. So they are comment. This is not considered as a part of the program. So, in the beginning of the program, you will add this comment to explain the main purpose of the program and who the developer is, and maybe the date of the last update, something like that. Then you can also use double slash, as you can see here. Then this is for the single line comment. You don't have to close it. Once you hit the enter, that's not the part of the comment anymore. So you will try it in the next week. Okay, next. In the beginning of the program, you will load this header file, the package of the functions. So most of the program, I may say 99% of the program, and 100% program in this course will load this standard input, output header file. So at least in this course, you may consider this is the default. You must write this line, shop include and stdio.h. So this shop sign is preprocessor directive. Preprocessor directive means before you begin the actual program, you're gonna give the instruction to the computer. So the first instruction before you run the program is to load this header file. Then you will say shop include stdio.h. So you have to exactly follow this grammar. Okay, so for instance, you want to use the mathematical functions. Then what do? Then you have to load math.h file. So for example, so this is comment. And then, so you will say shop include stdio.h. And then, if you want to use the mathematical function, you will say include math.h, like this. And if you need another header, include std library, standard library, then you will say like this. So this is the preprocessor directives. And mostly you will use this part to load proper header files. Okay, what's next? All right, then now you will define the main function. So this is also kind of default in the program, handled in this course. So you will say int, integer, and main function, main. So every C program must have one main function. And also you cannot have two main functions. So main function, and void means there's no input argument for this main function. And the integer int in front of the main function means this function will return integer value. So once you execute this function, you will write return 0. Returning 0 means this main function was successfully executed. So don't forget this return 0. Okay, and then inside of this main function, you will write the main body. Okay, so in this program, you want to display these two messages. This is my first program, and program is easy. This is lie. Sorry. Okay, and then to display something on your screen, you will use printf function. So this printf is included in this standard io.h. So you have to load this header file. Okay, then the something inside of this parenthesis is called as argument. So every function has argument, and for this printf, you will add something to display inside of this parenthesis. Okay, then now you will say printf and parenthesis. Inside of this parenthesis, type double quotation mark and write sentence. And close it with a double quotation mark. Okay, then you will display this sentence. This is my first program. Then, what is the meaning of this /n, \n? This is the special character with a certain meaning. Once you have this backslash, you will not display this on your screen. But instead, if you have \n, you will change the line. So the cursor will be moved to the next line on the screen. All right, then next. You have another printf, then you will display programming is easy. So you will display these two sentences. All right, then let me try this in my actual the IDE. So integer, main, and void. Then, I forgot to mention about it. So, in this main function, if you have a main function here, the range of the function will be defined by this curved bracket. So, between this curved bracket, you will write this main body. Okay, so coming back to this, the IDE, the black screen on your left-hand side. So once I write the main function, then I define the range of it with a curved bracket. And then let's type printf. Then you have this parenthesis, then double quotation mark, and what's the sentence? This is my first program. Then \n. And then next, once you write the one statement, you have to close it. How? You will say semicolon. So remember that this is very frequent mistake you are making. So once you write the one sentence, one statement, always close it right here. And then next, printf programming is easy. And change the line and semicolon, as you can see here. And then return 0 to end the main function. Okay. Then now I completed C programming here. So then what's next? You need a compilation. Can you find that? I have a typo. It has to be printf, but yes, I made a mistake. Printf. Then compile it. Yes. The building finished it successfully. Then I'm going to run this program. Run the code. And then, can you find these two sentences are displayed? This is my first program, and program is easy. Okay, then coming back to this statement, let me delete this \n. Then what would happen? We don't change the line, yes. So once I run the program, so this is my first program, and in the same line, program is easy, you can display it. So if you want to change the line multiple times, you can add this \n. Then what happens? Oh, sorry, I made a mistake. I have to use \n. Okay, then this is my first program, and I change the line multiple times, and next sentence is displayed. So this is how you can use this printf function. Okay, then this is the overall structure of the C programming. So I hope you remember this. So you will use this in actual the tutorial class. So first of all, write the comment. So you will explain what this program is doing, and you will write the name of the developer and the date as well. And then next, load header file. So by the default, you will load stdio.h. Then, depending on your application, you will load math, standard library, time, and so on. And then define the main function. Integer, int, main, void, and use this curved bracket. And don't forget, return 0. And then next, write the function body. So this whole structure is valid until the end of the half of this course. Okay, then let's move on to the second program about the addition. So we already practiced the pseudocode of the addition of two numbers. Okay, then why don't we write here? So, okay, then let me write the comment first. Adding two numbers. And then, shop include stdio.h, then integer main void, then use curved bracket. Then now, I'm going to write the main body. So first of all, we want to declare the variables. Oh, why don't you write the pseudocode here? Start and set number 1 and number 2. Then next, calculate sum. Sum equals number 1 plus number 2. Display sum. End. So this is the pseudocode. Then let's follow this. We need three variables, number 1, number 2, and sum. They are integer, number 1, number 2, sum. And after the statement, always use semicolon. Don't forget this. Okay, then let's set number 1 and number 2. Number 1 equals 10. Let's say 20. Then number 2 equals 30. Then calculate sum. Sum equals number 1 plus number 2. What's next? Printf the sum of %d and %d is %d. What is the meaning of it? Oh, thank you. Comma and change the line. And don't forget semicolon right here. Okay, at the end of the program, return 0. All right, so the code is done, and compile it and run the program. Oh, something's wrong. %d, sum of the %d. I forgot to add the variables. Number 1, number 2, sum. Okay, so this is the outcome. the sum of 20 and 30 is 50. Okay, then let me give you the explanation of this code one by one. So please look at this screen, right hand side. So in the first line, this is the declaration statement. So it declares 3 integer variables, number 1, number 2, sum. Then once you have this declaration, you reserve 3 memory space, as you can see here. So this memory cell is allocated to number 1, variable name. And this memory cell is allocated number 2. And this one is allocated sum. So this is the preoccupying the memory cell to utilize in this program. Okay, then type is integer. Then next. In this statement, number 1 equals 20. So in this memory cell, you store the value 20. Then next, in this memory cell for number 2, you store 30. And then after that, you have this calculation. Sum equals number 1, which is 20, plus number 2, which is 30. So you store 50 in this memory cell. Okay, then next, printf. This is quite complicated. So in this printf function, can you find this section? This section of the quotation mark, right? So you will display something between this double quotation mark right here. Then what is next? After that, you have comma number 1, comma number 2, comma sum. So you included 3 variables, right? Okay, so coming back to this screen. Inside of this double quotation mark, you are saying the sum of %d and %d is %d. What is the meaning of %d? %d is the specifier. So it tells you what to display, where to display, how to display certain variable. If you say %d, d means integer. If you have a different type of the variable, you will use the different specifier. For example, %f for the float point number. So each integer variable requires %d. And then now, I said specifier tell you what, how, where to display the value. So the location of this specifier tell you where to display. Okay, then this is the first D specifier. So then what is the first variable after this comma? Number 1. So number 1 will be displayed here, where the first %d is located. So you will display 20, and second %d, number 2, you will display 30. Then third %d is about sum, 50. So eventually you can display the value of the variables, as you can see here. So this is the syntax. Printf, then parenthesis, double quotation mark, Then type any word to display. Then add these specifiers and add the name of the variables after this quotation mark. So notice that the number of the specifier exactly matches to number of the variables. Okay, then let's try something else. So now, please take a look at the left-hand side. Now, I changed the order of the variables. Number 2, number 1, sum. Then what is the expected outcome? The sum of 30 and 20 is 50, right? Yes, exactly, right here. Okay, then, how about this way? I can directly enter the integer value 20, 30, and sum. So instead of this name of the variable, I entered the actual integer value. Then this integer will be displayed here. So the sum of 20 and 30 is 50. You can also do certain operation in here. Instead of sum here, you can say 20 plus 30. It is working as well. So you will display 50 in here. This is also possible. Number 1, number 2, and number 1 plus number 2. Yes, you can have the operation in here. Then you still display, yes, 50 right here. All right, so this is how you utilize this printf function. Do you have any questions so far? So, is it easy? Yes, go ahead. Like this, for example, 20 and 50. Yes, you can do that. You can do that, but yes, if you do this, you can display like this, exactly. But, you know, this is just merely displaying sentence. But if you have certain operation with various numbers, then you cannot change it. You mean the type number 1 here? Actually, this is not a grammar of C language. Because think about that. If you say number 1 right here, how do you know you want to display number 1 or value of the variable? We don't know about that. That's why we need a specifier. That's a very good point. Thank you. Any other questions? Okay, then let's move on. Third program. So now we want to calculate volume of cylinder. So in this previous program, you learned how to do the mathematical calculation when your variable has a certain value. So actually we tried 20 plus 30. and you display 50, right? So actually formula is a little bit more complicated to calculate volume of the cylinder, but as long as you know the formula, the overall structure will be similar with the previous calculation, the previous program, right? But in this program, we're gonna try something new, which is scanf. This is to obtain the value from the user. So in the previous program right there, you already defined the value of the number 1 and number 2 inside of the program, right? But if you use scanf, the program will ask you to key in the value. So let's try it. So okay, then now let's say I already loaded the header file and defined the main function, integer main void. And this curly bracket is the scope of the main function. Then in here, the first line, float, not int, because we want to handle the float point number, real number, with a decimal place, not integer anymore. So we want to use different type, float. Then we need 3 variables, radius, height of the cylinder, and volume. And don't forget semicolon. Then printf. Calculate the volume of a cylinder. And change the line and semicolon. Then next, printf, enter the radius. Then what's next? So if you stop the writing code, can you expect the outcome of it? It's quite obvious. You will only display these 2 sentences. Calculate the volume of a cylinder, enter the radius. Okay, then now I'm going to use scanf function. Scanf and %f. This is the specifier for the float point number and radius. Okay, then if you use scanf, what is the outcome? So let's try to run the program. Can you see that? I displayed the first sentence and then enter the radius. I displayed the second sentence, right? But this program is not ended. It is waiting my input, as you can see here. Then let's say radius is 12. Actually, I can type it. Then hit enter. Then program ends. Now I just executed scanf function. But in this code, I don't have a next part, so program is just ended. This is how scanf is working. So once you enter the value, this value is stored in the memory cell of the variable radius. Okay, then let's move on. Next, printf, enter the height. And don't forget semicolon. And scanf, %f and height. Then if you run the program, yes, you display first sentence, enter the radius, let's key in 12. Then hit enter, then you will see the next sentence. Enter the height, and it is waiting for my input. Then let's say height is 45. Then once you hit enter, you will end the program. Okay, so now you got the value of the radius and height. Then let's add more statements. Then what's going to be the next? Then calculate the volume. The volume equals 3.14. Times, how do you calculate the volume of cylinder? First, you have to calculate area of circle, right? Pi radius times radius times height. All right. Radius. Okay, now we calculated the volume of it. Then what's next? Display the outcome. Printf. Printf. The volume is %f. And change the line. Okay, now we have this specifier %f. Then at this location, you will display the variable volume, right? This variable. Then semicolon. All right, then let's run the code. So I displayed calculate the volume of a cylinder, first line, and second line, enter the radius. So let's say 12, 0.5. And then next. Then this 12.5 is stored in the memory cell of the radius. Then you will display, enter the height. Then what's going to be the height? 3.4. Then this value will be stored in the variable height. All right. Then you will calculate this and then display the volume is this value, the value of this variable volume. Okay, any question? Huh? Oh, this is very good point. Actually, it will be explained in the next week. But so integer only handles actual integer number. So let's say, let me give you an example. Now, type is integer. Now I change the type of this variable. Then, of course, I have to change it. In this case, let's run the program. So I want to say 12.5 and then 3.4. We already have an error. So once you enter 12.5, but only 12 will be stored. You cannot handle the decimal places if you use integer. And another example is, let's say, let's change the type float and F. Then you just maintain this %d to display value of the volume. Then what happens? You already have an error, right? It has to be float. So if you expect your number will be real number, you have to use float. But if you are 100% sure that the number is integer, then you may use integer. Then you may ask, okay, let me continue. Then you may ask, then why don't you use float every time? Right? So, it's the matter that there are two reasons. Number one, you want to save the resource. So, to store the real number, actually you have to allocate much larger memory cell. Yes, in this simple, very short program, yes, your computer already have the 4 gigabyte, 8 gigabyte memory cell. It doesn't matter. But let's imagine when we developed this program, 1970s, 80s, we are very excited about 1 megabyte memory cell at the time, right? So the size of memory is precious. And even for now, if your program is very big, then this management of the memory is very important to make it efficient. So if your number is integer, if you use float, it's waste of the memory. That's the number one. Number two, sometimes when you handle these numbers with many calculations, so the decimal place will be very nasty. And sometimes you may have unwanted decimal places. But if you set your variable as an integer, zero chance of having this nasty decimal place. Two reasons. Okay, Okay, thank you. All right, so coming back to this slide, so if you have this declaration, you have 3 memory cells with a float type. So actually, it has a much larger memory cell is occupied because the type is float. And then, yes, you need to use %f. Yes. Pi 3.14. Yes. Oh, you can, either way is fine. So I'm going to explain how to declare that constant later. Okay, then now you're going to use this specifier. Then now you can use a scanf function to obtain input from the user. So in this example, I used only single specifier, but you can also use the multiple specifier, as you can see here, if you want to receive the multiple input. Then when you give the space and define 2 variables, as you can see here, the 2 inputs will be stored in each, the variables. So sometimes you can use the different type of the variables, and not only 2, you can get the input of the 3, 4, 5 variables. Okay, so this is how you can use scanf. And notice that this is, okay, in addition to missing semicolon, this is a very frequent mistake you are making. When you use scanf, you have to add name of the variable in here, but you must add AND symbol only for this scanf function. So coming back to printf function, you use only the name of the variable, but this in this scanf function, you must add AND. So don't miss it. So I'm going to explain why in the last week of the lecture. Okay, so once you use scanf, the user input will be stored in the radius and height, and it will be stored in this memory cell. And after your calculation of volume, this value will be stored in here. All right. Then I would like to remind you the overall structure of the C program again. So don't forget adding comment in the beginning of the program. Then load header file, define main function, integer main void, and curly bracket. Then complete the function body. So up to week 5 in the tutorial, you will use this structure of the program. All right, then okay, then why don't we stop here? Then the next part will be resumed in the next week lecture. All right, do you have any other questions? All right, so thank you for your attention and see you next week.